Our moon is unique. Its gravitational influence keeps Earth's orbit regular, which helps stabilize the climate. Its cratered surface preserves a record of solar system history that wind and tectonic forces erased from Earth. That ancient story is still up there, waiting. In the 1970s, after the last Apollo landings, many expected new missions to follow fast. A lunar base, an orbiting station, even ideas about mining resources were on the table. Instead, the space shuttle became the cost-cutting solution, and human activity stayed in low Earth orbit. The International Space Station was finally completed, but only after the world banded together to share the price tag. Deep space exploration shifted to robots. Safety issues then pushed the shuttle into early retirement, and the long wait for a replacement left America flat-footed. NASA pivoted. Let private industry handle trips to low Earth orbit and refocus the agency on human exploration of deep space. Ambitious plans to return to the moon were sketched out, but Washington was slow to release funds. NASA had a human-rated spacecraft in development called Orion, paired with a new Ares launch vehicle under the Constellation program aimed at missions beyond Earth orbit. Ares flew once, then serious problems ended the program. Orion survived, reconfigured with help from the European Space Agency, which built a service module to cut costs. In 2014, Orion faced its trial. Exploration Flight Test 1 launched on a commercial Delta IV Heavy with a dummy service module and an incomplete launch escape system. The goal was simple: prove it could come back from the kind of speed a lunar mission would produce. After 6 minutes, the abort system separated. Orion was pushed to an apogee of about 5,800 kilometers, then plunged home. 4.5 hours after launch, the capsule bobbed in the Pacific and a team from the USS Anchorage hauled it aboard for analysis. A clean success. But at that moment, the only real plan used Orion for an asteroid retrieval mission that was soon dropped. Orion waited for a new rocket. That new rocket was the Space Launch System. In 2010, Congress authorized money for a big launcher, largely to preserve jobs and keep parts of the space industry alive. There were strings attached. Shuttle suppliers would supply the SLS. A Utah senator pushed for solid fuel boosters built and tested in Utah. Senators from Alabama and Florida supported upgrades that kept dollars flowing into their states. The SLS was framed as a mature, shuttle-derived vehicle, flying upgraded RS-25 engines and a core stage rooted in the external tank. Critics said the price would slow development and cap launches at around 2 per year. They argued it was outmoded before it flew, and that the budget left little money for anything except building the rocket. A big launcher with nowhere to go. Then came a lifeline. In 2017, a White House directive refocused the program on human exploration and a return to the moon for long-term exploration and use, with Mars in sight. There was no new money, but NASA moved. The Artemis program was born, and the agency sold the vision hard. The NASA administrator at the time was candid. Bold goals require real funding, or they will not be accomplished. The plan took shape. A new space station called Gateway, in a highly eccentric lunar orbit, would be a transfer point for crews heading to almost any point on the surface. It would also build up deep space operations experience for future Mars missions. Collaborate with private industry, NASA said, and bring ideas for Gateway and for a human lunar lander. The target was a landing in 2028. That target suddenly moved. In early 2019, the vice president said the United States would return astronauts to the moon within 5 years. Focus on the mission over the means. Consider every option across industry and government. He invoked a new space race mood, noting China's far side landing and Russia's seats to the space station. But details on funding did not come with the deadline. For context, the 1960s were different. The Soviet Union detonated an atomic bomb in 1949, launched Sputnik in 1957, and sent Yuri Gagarin into orbit in April 1961. The United States answered with Alan Shepard's 15-minute suborbital hop, and then a bold commitment. In May 1961, President Kennedy asked Congress to land a man on the moon and return him safely before the decade's end. The nation backed NASA, led by James Webb, who secured the money and built an enduring infrastructure. Apollo 11 touched down in July 1969. The deadline was met, interest faded, and later, Apollo missions were canceled. Back to today's race. NASA calculated that an accelerated return needed an additional $35 billion. It did not arrive. Gateway was dropped from the 2024 plan, and industry was asked for lunar lander concepts. In 2020, Dynetics, SpaceX, and a team led by Blue Origin received seed money to start design work. Many feared a change of administration would end Artemis. Instead, a new administrator, Bill Nelson, supported the program and favored traditional cost-plus contracting. Side by side with this, SpaceX showed a different model. Crew Dragon completed testing in 2020 and began ferrying astronauts to the station. Boeing's Starliner, built under a conventional approach, was more expensive and suffered setbacks. SpaceX pushed hard on reusability. Since 2017, Falcon 9 first stages routinely return, cutting costs and undercutting rivals. Falcon Heavy strapped 3 cores together and landed twin boosters in formation. The upper stage could not be reused, so SpaceX rolled out a new idea: Starship. A towering system with the Super Heavy booster returning to the ground, and the Starship upper stage re-entering belly first. At its heart is the Raptor engine, burning methane and liquid oxygen for reliability and reusability, and using autogenous pressurization to save weight. At Boca Chica in Texas, prototypes rolled out fast. Starhopper flew to about 150 meters. SN5 and SN6 performed low-speed hops on a single engine to refine procedures. SN8 debuted the full Starship profile with 3 engines. In December 2020, it climbed to over 12 kilometers, performed the dramatic belly flop, and fed back data. SN9 followed, but an oxygen preburner issue left only one engine relit with reduced thrust. SN10 ignited all 3 for the flip, came down hard, bounced, leaned, and small fires burned at the base. Helium in the header tanks had mixed with fuel and reduced thrust. SN11 lifted in heavy fog and exploded aloft after a hard engine start. In April, NASA picked SpaceX to build the lunar lander, a Starship variant that can dock with Orion. 2 companies had been expected, but with less money from Congress, cost took the lead. A Senate hearing followed as Bill Nelson moved toward confirmation. The 2024 date remained on paper, ambitious and widely doubted. NASA's $2.89 billion into Starship's lunar version eased the load for SpaceX. Meanwhile, NASA poured resources into ground infrastructure. Pad 39B got a massive upgrade. Lightning towers were refurbished. New tanks were installed. Crawler transporters from the Apollo and Shuttle eras were rebuilt for SLS. The crawlerway was refreshed. Recovery teams practiced hauling a 9,000-kilogram capsule aboard a Navy ship off California. It is effective, but expensive, and it looks old school next to the idea of propulsive landings. SLS development moved through the Green Run test campaign at Stennis Space Center. Engines, tanks, avionics, and controls were put through their paces. A first hot fire shut down early because of conservative software and was run again. The core then shipped to Kennedy. Elsewhere, delays hit SpaceX. The Federal Aviation Administration conducted an environmental review of Boca Chica, a site near a fragile lagoon system. Explosions and debris raised alarms, and launch cadence targets exceeded original agreements. There was also a technical bottleneck. Raptor engines were not being produced fast enough. Legal action by Blue Origin over the lunar lander slowed NASA and SpaceX for months, and pandemic disruptions piled on. NASA slipped the first landing to 2025, while its Inspector General warned that lander development and spacesuits were still early, making any near-term date unlikely. Even the first uncrewed SLS launch slipped. Issues with an RS-25 engine controller only showed up after the rocket was stacked. NASA does not directly release the combined cost, but estimates suggest just over $1 billion per launch with a cadence around one per year. With Starship targeting similar capability, many ask why NASA and SpaceX cannot align more closely. Finally, Artemis 1 lifted off on November 16, 2022, sending Orion around the moon and back without a crew. Work continues on Artemis 2, the first with astronauts. The moon is calling again. The question is simple. Will a government rocket with strings attached or a private giant built for rapid reuse put humans back on the lunar surface to stay?